So the next talk is going to be given by Nick Feamster. Nick Feamster is a professor at Georgia Tech and has done a lot of really interesting work over many years in the area of software-defined networking, including deployments in the Georgia Tech campus network. And he's going to describe some of his recent work on enabling event-driven programming on top of software-defined networks.
Thanks, Jen. So I'm going to talk about how we've used software-defined networking to tackle a particular class of problems, in particular what I like to call software-defined network management. So a lot of the work that I've done over the years has been in designing tools, algorithms, and so forth to help network operators do their jobs better. And the advent of software-defined networking has opened up huge possibilities in this space in terms of helping operators do things either more easily or do things that they wouldn't otherwise be able to do. So when I speak about network operators today, in general, I'm talking about campus and transit network operators, but also towards the end of the talk, we'll see that as I talk about home networks, the network operator is you. So you may care about some of the things that I'll talk about towards the end of the talk as well. Okay, so jumping in a little bit, why is network management and why is network configuration so hard? Well, we heard a lot about that in the previous talk, right? One of the things that Nate mentioned is that configuration just changes super frequently. So one thing we did was to look at the changes that occur in the Georgia Tech campus network. We did this for a couple other campuses as well, but I'm showing you here some statistics in terms of adds, changes, deletions, et cetera, to the low-level switch, router, firewall configurations over the course of about a 5-year period. So if you kind of do the division, what you basically see is that on average, a network operator is making anywhere between several hundred to 1,000 changes to the network configuration every day. Okay, now, of course, these aren't, individual manual instances. They're probably scripted, et cetera, but effectively what you've got is a lot of changes, a lot of churn happening to very low-level configuration. Right, so here's basically some examples of the types of things that are happening, right? As the previous talk also mentioned, a lot of the things that change involve, for example, changes to access control. So there are a number of problems with this, of course, the biggest being that errors are quite frequent. But also, operators need to determine what's going to happen when these changes are made and whether or not the configurations are going to be correct. So these are big problems. We just heard about them. We heard about one particular approach. And what I'm going to propose in this talk is, what if we could just make the need for applying these configuration changes go away entirely? What would we need to sort of eliminate a lot of the need for these configuration changes? How would we automate things? Well, the insight for the idea that I'm going to tell you about is, well, a lot of network configuration, a lot of what we want to tell the network to do is basically event processing. Right? We basically want to say, when a particular thing happens, or when a particular condition is true, take this action. Well, today's network configurations are just horrible at doing this, right? That's why we see so many configuration changes. That's why we see a lot of this happening in a very manual way. But what we'd like to do is, and these are the types of things that either users have told us that they'd like to do, or that we've gotten either from talking with network operators. These are the types of things that we would like to just basically make happen. And the annoying thing about today's network configurations, right, is that none of these things can happen automatically, right? If you look at any of these examples, they invariably involve waiting for an alert, waiting for something to happen, and then going in and tinkering with things, usually at a very low level. Well, let's see what we can do to try to make these types of things go away, right? To just, write the policy once and for all, right? And then never have to go back and touch the low-level configurations again. That is basically the idea of Lithium, which is what I'm going to tell you about today. Effectively, this is an extension to OpenFlow-based network control, and I'll describe to you exactly how it extends that control model. But the idea is basically to express network control or express network policies as event-based programs. So typically, we think about networks as having the data plane and the control plane. And what I'm going to talk about is sort of how we extend that control model so that we can also talk about events. Right? So when these events occur, we have a very well-defined notion of what's supposed to happen, what the network is supposed to do. In a nutshell, this is basically what we do. We basically we take the OpenFlow control model and extend it in a very simple way. So the basic OpenFlow spec, typically, it only operates on these flow properties, right? We're all very familiar with that. here's basically how Lithium extends that. Right? So typically when we think about open flow control, we think about flow characteristics and then actions that may take place based on properties of particular flows. And what we do is extend that set of conditions so that we're not basically taking actions just on flows, but we're taking actions on what we call additional policy domains. So in particular, we look at taking actions based on time, and that may be time of day, it may also be time of month, time of year, etc. Based on history, i.e. what's happened in the network in the past. In particular, if we looked at those previous examples, how much traffic has a user sent for a particular application over a particular time interval, right? And user, right? So who this particular user is. Is it a guest, right? Is it a privileged user? So on and so forth. Now, I'll quickly point out that there are other policy domains that we could go about expressing. And these we basically picked because they were motivated by examples of the types of configurations, of the types of policies that I showed you before that network operators and users actually said that they wanted to express. And it turns out that these three additional policy domains give us the ability to express a wide range of things that people want to express. And a fairly good bang for the buck, if you will. But by no means are these the only three policy domains we could talk about. So that's the basic idea in a nutshell, is extend the control model so that instead of taking actions just based on flow, we're taking them on these wider range of policy domains. Great, simple idea. How do we actually do it? Well, before I get into the nuts and bolts, let me just give you a bit more details about what I mean by these policy domains. So, for example, the time domain might be, as I mentioned, on fine-grained time. It might be do things only, behave a certain way during peak traffic hours and do something else during off-peak. It may be depending on time of year. For example, if you're a campus network operator, you may actually do different things in the summer versus during the academic year. History. This may be things, for example, like how much has a user sent over, how much data has a user sent for a particular application over some time interval. It might have to do with the rate at which the user is sending, and so forth. User domains, as I mentioned, this might involve sort of the identity of a user or the group to which a user belongs. Okay, so how do we actually handle these events? What I'm showing here in this rectangular box is essentially what's inside of our controller. So this is essentially like the controllers that we're all familiar with, except we've extended it to include what we call a dynamic event handler. Basically, what this event handler does is listen. Right? It listens for different types of events, and those events may be generated from different types of entities that relate to those policy domains that I mentioned before. So, for example, you might have, for example, a history database that maintains information about how much traffic a user has sent over a particular time interval. If a user exceeds a particular usage cap, for example, that database or that repository might generate an event to the controller that the controller then processes. Similarly, time is another type of event that the controller either maintains internally, or there might be other types of time events that arrive externally. So the controller basically is implemented as something that just listens to events, and then based on what events it hears, right, it figures out how to update its state based on what those events are. And as I mentioned, these events can be both internal and external. What are those states? Well, the states actually are quite simple. These are just sets of domain values. So I talked before about time, user, history, and also the existing things we know about, properties of the traffic flow. So any set of domain values represents a state. And an event is nothing more than changes to those states. So various external event generators might trigger changes to these domain values, and that's essentially what we think about as an event, is a change in any of those states. Examples of those types of things might be, for example, the arrival or departure of a host. For example, a new user has arrived. It might be an intrusion, right? So we might imagine an intrusion detection system that's generating events, right? And our Lithium controller basically knows then it's capable of processing such an event, and given the appropriately defined policy, knows what to do in the event of a particular action. An example of that might be, for example, suppose that the intrusion detection system has recognized that a particular host has been compromised. Well, what do we do today? Well, basically the operator has to scramble and do something, right? But the operator might instead, using this type of event-based network control, define ahead of time something more sophisticated. So for example, if the intrusion is detected and the machine is a guest machine, we might cut that machine off entirely. If, on the other hand, it's a more privileged user, we might redirect them to a garden wall where they're capable of downloading patches. So that just gives you an idea of sort of the richer types of policies that are possible with this kind of event-driven network control. You might be wondering, how do we go about expressing those things? And I'm going to come to that towards the end of the talk. But that just gives you an idea of the richer set of events that we can process in this model. Just to give you an idea of the current implementation, we've extended Knox with some additional plumbing to do this kind of event handling. The policies right now in this current implementation are a modest amount of C++ programming. You might think, oh man, I've just moved from like low-level Cisco config to C++. That is not much better. And we agree with you. And I'm going to come to basically what we're doing about that towards the end of the talk, is how we actually are extending what the Lithium controller currently enables to allow operators to define higher-level network policies without this kind of general-purpose programming. As it turns out, there are some certain language constructs that are very well suited to defining these types of policies. So that's essentially what Lithium does. And I'm going to talk a little bit now about a couple real-world deployments where we're exploring the capabilities of Lithium. If you were at the last Open Network Summit, you've seen a little bit of this, so I'll go through it a little bit more quickly. But this will just be considered a refresher, and actually in the second part, an advertisement or a sort of call for participation, if you will. So I'm first talk about how we're using Lithium to simplify access control in campus and enterprise networks. In particular, what we've done is work with the campus network operators at Georgia Tech to re-implement how they've done access control in the Georgia Tech campus network. And we have a deployment of this running on a small portion of the network. In the second part of this part of the talk, I'll talk about how we've used Lithium to implement a usage control system for access for home networks. It's very difficult to do this type of thing today. People are scrambling for it, and as it turns out, what we can do with Lithium is basically design an outsourced network control system that's actually very simple and actually very easy for us to put very simple and intuitive user interfaces on top of it. And I'll show you an example of that user interface as well. So briefly, just to give you a flavor, this is how things work. As I mentioned, if you were at the last summit, you saw this. But just to remind you, this is basically how access control works. At today's campus network, a host shows up with a new MAC address. The VMPS figures out, OK, I haven't seen this host before. Let's put it on. Are we here? OK, see how complicated it is? The host says, OK, I haven't seen this before. Let's put this on a VLAN with a private IP. Right? At that point, the host can only get to a web authentication portal if the authentication succeeds. The VMPS reassigns that host to a public VLAN where it can get out to the wild woolly internet. Of course, this doesn't fully work because the host actually has to get its IP address reassigned. So typically, they've got to ask the host to reboot. This is a huge pain. You might imagine this being a bigger pain if later, so for example, going back to my previous example about intrusion, right? If we want to move this host back to off the wild woolly internet, now we're in big trouble because we can't actually ask a user to reboot just so that we can remove their network access. So there are a bunch of problems with the current approach, right? It's too coarse-grained. It's tough to remap hosts to different portions of the network. And it's very difficult to automatically process these changes as well. You can imagine, for example, after we put the host on the network, right, we still want to scan. We want to make sure that it's behaving properly. And if something bad happens, there's no way to sort of automatically take action. Right. So what we do with Lithium is allow the network operator to define, and I showed you, for example, that state machine. What we allow the network operator to do is define basically what should happen to a host in particular states. So we define a bunch of states. For example, when the host first shows up, we define a registration state and a bunch of forwarding rules associated with that. If if the host successfully authenticates, that's basically an event, right? So previously, what I talked about before in terms of domains, this is a change of state. Now, what the controller can do is push new forwarding table rules to the switches based on the fact that event has occurred, and we can of course extend this depending on whether or not authentication fails, or if later, for example, a vulnerability is detected, we can move the host back to a sort of a different state. Okay, so that's the basic idea. There's a deployment. We've basically put this in 3 buildings across the campus, and we're running this with across multiple research groups on the campus pretty much without incident. The other example that I wanted to describe is usage control. So network management in homes is a huge challenge, as I'm sure we're all aware. We're all too very well aware. And one particular, I'm going to just talk about one particular aspect of home network management today, which is usage control. In particular, by that I mean management of usage caps, right? But this could also mean other things like parental controls or management of bandwidth. Probably all of us, even those of us who, like to think of ourselves as, enjoying tinkering with networks, typically we don't like to do it in our spare time when we'd much rather be doing something else. So while I tend to think of this as, we often tend to think about, user interface problems as things for unskilled users, I'd also appeal to a broader set of users, which is the uninterested set of users, right? And I think when a lot of us basically want to, just have a Skype call or stream Hulu or Netflix or something, we may be skilled, but we're certainly uninterested, right? So one idea here is, to the extent possible, can we outsource network management, right, or control of the network? And in particular, let's have the home router run an OpenFlow-enabled switch. In the case of usage caps, let's have that switch or that router report usage of various applications, various users and devices to an offsite controller, and let's have the controller adjust the behavior of traffic depending on what events it sees, right? So again, this is the same problem as before, right? It's just that instead of the events being access control related or authentication related, they're now related to history or usage. So we're going to use that history domain. So usage control, I don't probably need to motivate very much, but in particular, we've seen a rollout of various usage caps. In other countries, actually, these usage caps are quite a bit lower, and as we know on mobile devices, they're also quite a lot lower. There are interesting developments going on as well with usage caps because, as we're seeing the evolution of these caps, we're seeing it's not necessarily a strict cap on all data, right? We're seeing things like certain types of applications, certain destinations, et cetera, being unmetered or uncapped. Right? So this problem is going to become increasingly hard to monitor and manage. So as I mentioned, what we do in this case is for the user, we try to basically make the control or the configuration of the network go away as much as possible. Right? So this relates to the theme before of automation, right? Except not only are we automating now, we're basically pushing that management into the cloud. So at the bottom here, basically, we've got our home network. We've got our typical wireless router sitting between that and the rest of the internet. But the OpenFlow controller now has basically moved out of the home, right? So we can rely on, it need not be out of the home, but in this case, or for the sake of argument, just to show you that it need not be in the home, this is basically one example of how we might do this, and this is basically what we're doing in our prototype implementation. Here, essentially, the user is going to, and I'll show you the user interface in just a minute, but the user is basically going to set policies through a graphical user interface. That's going to update basically a database that maintains what those, what usage should be. The OpenFlow-enabled router sitting in the home continually sends updates regarding usage back to that controller, and then based on those events, the controller will then take action back on the switch that's in the home to sort of realize those policies. So the interesting thing here is that all the configuration, all the control is actually happening outside the home network. So the interesting thing here as well is I'm going to sort of talk a little bit about the configuration language itself in just a minute. But the other interesting thing about the control model that we've developed is it makes it very easy to develop intuitive management interfaces. So I probably don't need to show you the nitty-gritty Linksys and Netgear configuration screens that we've all seen. But here is basically the alternative to that, which is essentially something that we've designed. It's called UCAP, and we're doing this in conjunction with HCI researchers who actually are not networking experts, right? So this is an interesting thing. This is an interesting collaboration that SDN has enabled. So basically, what the interface shows are things like, for a particular device, what's its current usage for a particular time. It basically allows users to set what that cap might be for a particular user, device, or application. And it also does things like allow users to get notifications. So for example, a user can say, send me a notification when a particular application or device is approaching its usage cap. So leaps and bounds ahead of what's possible today. Evaluation. So the qualitative stuff, actually, I'm gonna skip over, but I'm gonna appeal to your help. Or I'm gonna appeal for your help. If that application or that interface that I just showed to you looks interesting, we are basically trying to do a user study right now. So if you would like a home router with that usage cap interface, please get in touch with me. We'll be very happy to set you up. If it makes you feel better, I'm running it at home, and my grad students are controlling the usage caps, and I haven't experienced any horrible downtime just yet. And I've put control in the hands of my grad students, which is a huge leap of faith. Quantitative stuff, I'll just show you briefly. The upshot here is that it works. In terms of the campus network stuff, the performance overhead is essentially negligible. If you were to deploy the OpenFlow / UCAP control in your home, basically what you'd see is that as long as your traffic from the home network out on the access link is less than 20 megabits per second, you're going to be fine. The reason that we're slowed by that right now is the user space implementation of the OpenFlow OpenWRT switch. I expect that if anyone is interested in doing a kernel version of that, then we'll see much better performance in the home as well. Other things also seem to be quite within the range of feasibility. Okay, so just to close, just talk about the current challenges that we're working on. So I've spent the talk really focusing on the power of what event-driven network control can give us, right? And sort of the potential that it offers for simplifying network control. But you'll notice what I haven't described to you yet is what that language looks like, right? What is the alternative to Cisco configuration or Juniper configuration or low-level switch and device configuration? And basically what we need is some kind of high-level language to configure these policies. And as I mentioned right now, that language in the Lithium controller is C++. Well, that's not much better. We'd like to enable network operators to configure these policies without having to resort to a general-purpose programming language. There are a number of reasons why general-purpose programming doesn't work well, I should say. One is that enumerating all cases is very tricky. So let me show you an example of that in just a minute. Here are some goals that we want from the language design. We want it to be reactive. We want it to be very easy for operators to compose. So this is one thing that's very difficult in configuration today, right? So for example, if you have access control rules and you have load balance rules, how do you make sure that those things interact well? So that's something that we're working on. We want it to have well-defined semantics and have it easy to check, make it easy to check errors. So just to give you a very simple example, right? Here's something that has come up both in the usage cap examples and also in campus networks. So ban the device if the usage exceeds 10 gigabytes in the last 5 days. Great, that's a very easy thing to express in existing higher level control languages like Martin's FML. But once you start adding additional predicates, this gets increasingly messy. So for example, if on top of that you want to add conditions like remove the ban if usage drops below 10 gigabytes or remove the ban when an administrator resets, well, for every one of these predicates, you need to add a new condition. And your language starts, and enumeration of conditions starts to get very messy. So basically what we've done, or what we're working on now, is basically how we can leverage a construct called functional reactive programming to allow network operators to program their networks in a way that basically takes advantage of the fact that effectively what the policies are an event processor. So I don't have time to get into the details of what this is or what this all the details. But effectively, what happens is that we can design the controller as essentially a signal processor, right? As a signal function, which basically takes as input some conditions, right? And then outputs some constraints in terms of what should happen to a flow. So, for example, whereas before, for example, has the administrator, lifted the ban, or has the usage dropped over the last 5 days? Those are all if-then statements, and you can imagine we get a combinatorial explosion very quickly. If we are able to encode this as a set of signals and operations on that set of signals, we can do this a lot simpler, in a lot simpler way. So that's essentially the idea. We have a version of this basically implemented in a FRP language called Nettle, which is based on Haskell, and we're working on extending that and making it available now. So in summary, network management is quite difficult. It's quite error-prone. One of the major reasons that it's so error-prone is that changes are happening all the time, right? And what I've tried to impart to you today is what if we could take a different approach, which is that what if we could basically automate many of those changes away by expressing those policies as actions that should happen when particular events occur? I've described a controller called Lithium, which enables that kind of event-based network control, and I've described how we're deploying it in 2 real-world settings. I concluded with a brief discussion of the high-level control language that we're in the process of developing, and I'm happy to take questions now, but just to remind you, if the home network application looks interesting to you, we are interested in users for that, and we're interested in getting your feedback on that. So we're happy to explore that further. Thanks.
Yeah, we're running a bit over time, so let me just take one question.
Tina Zhou from Huawei. I have one question. Is it like FML, or is it like package C, or is it like API? What is it?
It's easiest to think about. So in terms of the language, it's easiest to think about it as FML-like, but with certain extensions. So the thing about FML, right, is that it doesn't handle these temporal conditions very well, and it doesn't allow the operator to basically express things that you could imagine like that toggle. So for example, you could have something like is it between 10 a.m. and 5 p.m. and has the operator reset the ban or not? Each one of these things can be expressed in FML, but once you start composing a huge set of conditions, it becomes very the expression of those things explodes very quickly. And basically what the language that we have enables is a much more concise way of expressing those sets of conditions.
Yeah, just one minor quick. Does it fit into the ONF configure and management working group?
It could.
Yeah, but we use different things in that working group.
Sure. I mean, I'd be happy to learn more about what's going on in that working group offline.
Thank you.